These notes are for January 11th, January 12th, or if you're on 3B, 4B, this would have been January 17th. What we're going to look at is deriving the double angle formulas for sine and cosine using the sum and difference formulas. Now, I would highly recommend, if you're not familiar with these, go back to the previous videos, look at using the sum and difference formulas, how we use them, and so on. But here we're actually going to use these formulas to derive a double angle formula. And in class, what we said is it'd be great if we could figure out, instead of having 2 theta here, if we could split 2 theta up and split it up as addition. Or in other words, if we could have something plus something equal 2 theta. And what we said is this would become sine of theta plus theta. Since if you do theta plus theta, you would end up with 2 theta. Now what we can do is, now we have a sum inside of our sine function, we can use our sum and difference formula, but instead of alpha, our new alpha would be theta, our new beta would be theta as well. So we just use the formula, but instead of alpha and beta, we'll use theta. So this would become sine of theta cosine theta. Since we're using addition here, we look at the top, addition's on top here, addition is on top here, cosine theta, sine theta. Now we can simplify. Here we can say this is sine of theta plus theta. Now in class what we noticed is this is sine, cosine, cosine, sine. But we talked about like 2 times 5. 2 times 5 is 10, but so is 5 times 2. Or in other words, if we have multiplication, we kind of rearrange the numbers any way we want. Same thing here. We can say, if it helps you see it, this is equal to sine theta cosine theta. And then I'm just going to rewrite this instead of cosine sine. I'm going to write it as sine cosine. Now hopefully we can see we have 2 terms, this term and this term separated by addition. They're the same thing, so we can actually combine that. And what we end up with is that sine of 2 theta is equal to 2 sine theta cosine theta. Because we have sine theta cosine theta, we have 2 of them, combine them, you get 2 sine theta cosine theta. And this is our double angle formula. So now, anytime we see 2 times an angle inside of our function, if it's beneficial, we can replace sine of 2 theta with 2 times sine theta cosine theta. And we'll see how we do that in a second. Now, I would highly recommend doing the same thing here. We can say this is cosine of theta plus theta. Plug it into your formula. Try it. Try it on your own. I would pause it here. Try, plug that in. Instead of alpha and beta, you would have theta and theta, theta, theta. And what we would find is that cosine of 2 theta is cosine squared of theta minus sine squared of theta. Oh, sorry. So now we have these double angle formulas. These are our double angle formulas because inside of your function you are doubling an angle. You're multiplying an angle by 2. So I'm going to write these here just for reference. 2 theta. Now we're going to do something similar to when we did sum and difference. We're going to verify these work. We're not proving anything. We're not getting any new values. We're just showing that they work, verifying that they work, and seeing how the formulas work. So for example here, we already know what cosine of 4 pi over 3 is. We know, based off of the unit circle, that cosine of 4 pi over 3 is -1/2. Now we're going to use the double angle formula to verify that, or not verify, to kind of show the formula works. Show it works and see how it works. So what we would need is, we would need cosine of 2 theta, or in other words, 2 times an angle to give us 4 pi over 3. So here we need 2 times something to give us 4 pi over 3. And in class, we decided that thing would be 2 pi over 3. 2 times 2 pi over 3 would give you 4 pi over 3. Now we have 2 times an angle, similar to here, 2 times an angle. We use our formula, but instead of theta, put in 2 pi over 3. So this would become cosine squared of 2 pi over 3 minus sine squared 2 pi over 3. Ultimately, we should end up with negative 1/2. Now, one thing here is, I'm right over here. So these are our double angle formulas. If we have cosine squared of an angle, this is another way you could read this, is take the cosine of that angle and square it, which is what we're going to do here. What this is saying is find cosine at 2 pi over 3. Cosine at 2 pi over 3 is negative 1/2. So it says find that first, then square it. Same thing here. Sine at 2 pi over 3, square root of 3 over 2, then square it. Now if we do this, what we would end up with, negative, we're squaring it, and negative times a negative is a positive. Now what we can do is square the numerator, square the denominator. 1 squared is 1, 2 squared is 4, minus, come over here, square root of 3 squared would be 3, 2 squared would be 4. Now we simplify. Oh. And negative 2 over 4, that equals negative 1/2. Which is what we wanted. I'm going to get started on the second one and let you try it on your own. Here we know sine 90 degrees. 90 degrees, same thing, I'm going to do this. Same thing as pi over 2 in terms of radians. So sine of pi over 2, this should be 1. Now we get to verify. So to use the double angle formula, we need sine of 2 times an angle. So 2 times something would give us 90 degrees. That something is 45 degrees. Or if you like radians better, that's 2 times pi over 4. So now we have 2 times an angle. Our angle is theta. So we can plug pi over 4 in for theta. Plug it in, simplify. What you should end up with is 1. I'm going to let you do that on your own. Make sure you're doing it right. If you have questions doing that, please let me know and I can clarify. In the second video, we're going to see how these double angle formulas are used. Talk briefly about why they're not very useful to get new values, and then solve equations.